In section 6.4 of our text, there's several already defined Maclaurin series to match a function. So I pulled out one row that looks like what we have going on here. It's just a little bit different. What we'll want to note is that the row I pulled out has 1 plus x, and right now we have 1 minus x. We can make a switch there. Just make this be a negative x. So we have our r. X is just going to be negative x. That's just going to mean it's going to alternate. So if we use the formula for this Maclaurin series, it's a sum from n equals 0 to infinity of our r. R is 1/3, and I actually had to look this up when I started using this text. I did not know that you could have fractions in the binomial formula there, but r is 1/3, and that's over n times x to the nth power. So we're able to do this because of previous work that the book had done. The book had proven that this function can be rewritten in this form. So we just coerced our function a bit. We rewrote it as plus and negative. Oh, sorry, there's one last piece. Yeah, the whole part about rewriting it so it's plus and negative x, all that's going to do is that's going to change your term so that it's alternating. Remember, because the Taylor series, you're taking a derivative each time that you make a new term. And when you take a derivative, the chain rule is going to make a negative sign come out. So it's going to keep alternating from plus to minus. So this is missing one last thing. Is it n or n to the n plus 1? That depends on the first term. I think we got to just do it real quick. The first derivative is 1/3 1 minus x to the negative 2/3. So the first term would be f of 0 because it's a Maclaurin series, so we're using 0 as our center, plus the derivative of f at 0 times x to the first power. So if you plug in 0, you get out 1. The first derivative, plug in 0, get out 1/3 times x. And then this, whoa, no, negative. I missed that. That's a negative 1/3 x. Because when you take a derivative of the innermost function here, a negative sign comes out. So the first term needs to be positive. So that means this needs to be n, just n, because we're plugging in 0 in for the first term. So there's our Maclaurin series.